Now, common ion effect means that supposing I take a weak electrolyte. This is a weak electrolyte, acetic acid. This dissociates into acetate ions and H plus ions. But to this, if I add a strong electrolyte, this is a strong electrolyte because it is made from sodium. All compounds of sodium form strong electrolytes. So if I add a strong electrolyte to it, there is a common ion effect because acetate ions are here also. So these ions are in common. So when the ions are in common, it means acetate ions in the product have increased. If acetate ions have increased, the reaction is going to shift in the backward direction. You learnt in Le-Chatelier's principle. If I increase the concentration on the right, reaction will shift to the back. So this is called that to a weak electrolyte, if I add a strong electrolyte, its dissociation is suppressed. Suppressed means becomes less. So, common ion effect means that to a weak electrolyte, if a strong electrolyte is added, having a common ion, the weak electrolyte starts dissociating less, that is reaction shifts in the backward direction. Similarly here, if I to ammonium hydroxide, which is a weak electrolyte, if I add a strong electrolyte because this is a salt made from HCl, this is chloride, so salt made from chloride. So it is a strong electrolyte. Again, a common ion is present here, which is ammonium ion, and this ammonium ion, increase of ammonium ion shifts the reaction in the backward direction, which means the dissociation of ammonium hydroxide is suppressed, becomes less. So common ion effect causes the reaction to go slow in this direction. So dissociation of ammonium hydroxide gets suppressed. Now both these things we also use in a buffer solution. So a buffer solution. This is an application of common ion effect which is called a buffer solution. So there are two types of buffers. One is called an acidic buffer. So you will say an acidic buffer is a mixture of weak acid and its salt with a strong base. What it means is that CH3COOH is a weak acid. If I react it with a strong base, which is NaOH, I will get CH3COONA plus water, which is acid plus base gives salt and water. So this is a salt made from a strong base. So what we are taking here is a weak acid mixed with a salt of a strong base. Then again same effect will take place. Now a buffer solution is a solution whose pH does not change. Even if I add an acid to it or I add a base to it, pH does not change. So how it does not change? Let me do one by one. So this is a buffer solution, mixture of these two. If I add an acid, meaning H plus ions have increased. Now these H plus ions combine with acetate ions to form acetic acid. Now acetic acid is already very weakly ionized because the reaction is shifting on this side. So no change in pH takes place. If I add a base means OH minus ions. OH minus ions combine with H plus ions to form water. So that means in both the cases, there is no change in pH. Now see, I have used these acetate ions with H plus ions because more quantity of CH3CO ions are present from this. This is a strong electrolyte. Arrow is only one side. It means all of it has changed into acetate ions. These are in larger quantity than this one. So H plus ions combined with this to form acetic acid. but acetic acid's dissociation is already suppressed due to common ion effect. That is why no further change in pH will take place.